Hello. So today we will continue our talk on crystal vibrations, right? And in the last two lectures, we discussed the case when we have a lattice with only one atom basis. That is, all the lattice is made up of only one atom. Okay, whether it is sodium, whether it is iron, whether it is gold, it is made of only one type of atom. Today, we will discuss the case when we have two types of atoms. So we call it diatomic bases. So consider it will look something like this. Okay, so again, these atoms, now instead of calling them all U, I will have some U atoms and some V atoms. Okay, look here, I differentiated between them by making U smaller than V. Okay, and they are connected by these bonds, which are like springs that have spring constants C. Okay, and we will assume that the two atoms have two different masses. So US has atom mass M1 and V has mass M2. And the distance, that is, if the lattice is not moving, the distance between US and US plus 1 is A. Okay, but in reality, what's happening is that this distance is fluctuating. So consider a one-dimensional diatomic mass and spring crystal where the unit cell is of the length A, and each unit cell contains one atom of mass M1 and one atom of mass M2 connected together by a spring with a spring constant C, as shown in the figure below. Consider the case where all the springs are all identical. Okay, so we're not gonna say we have different spring constants. They all have exactly the same spring constant C. Motion of particles is in one dimension. This will also facilitate to us the math we're gonna do. And the interaction limited to nearest neighbors. So US will only be affected by VS and VS minus 1. It will not be affected by US plus 1. Okay. Now, in order to write the equation, so let's look at M1, for example. Applying the Newton's second law, we will have M1 US double prime is equal to C. Okay. Now we have VS minus US minus C US minus VS minus 1. So just compare it to what we did in one dimension. It is exactly the same, but here the atoms affecting US are not US plus 1 and US minus 1. They are VS and VS minus 1. And this is why we get this equation. Now, for VS, it is very similar. We have M2 VS double prime is equal to C US plus 1 minus VS minus C VS minus US. It is affected by the two atoms US plus 1 and US. Now, again, exactly like before, we look for wave-like solutions where US is U E I K S A E minus I omega T and VS is V E I K S A E minus I omega T. And our job is to find a relationship between omega and K that fulfills these two equations. Okay, let's start. So if US is U E I K S A E minus I omega T, then US double prime is minus I omega square U E I K S A E minus I omega T. I simply took the second derivative. If VS is this, VS double prime is similar. Now we substitute in the two equations. Okay, so I will have M1. Instead of US double prime, I will put minus I omega square U E I K S A E minus I omega T. This is equal to C. Okay, VS minus US, so it is V I E I K S A E minus I omega T minus U E I K S A E minus I omega T minus C into US minus VS minus 1. So I have EU E I K S A E minus I omega T minus V E I K S minus 1A E minus I omega T. For the second equation, it will look very similar to the first equation. Okay, so I will just substitute all the values. And now what we're gonna do, so we substitute. Now we will simplify by EIKSA E minus I omega T. So I'm gonna take these ones as common. Okay, notice I have it here, so it will go out. I have it here, it will disappear. I have it here also, okay? And I have it here. Here I have it, but there will remain one thing, which is E minus IKA. Okay, now for the second one also, I have it here. I have it here. I have it here. I have it here. And here I have it, but I will be left with EIKA as well. So what will I have? What will remain here is minus M1 omega square U equal to C into V minus U, okay, because whatever is in red, I eliminated it, minus C into U minus, now if I eliminate EIKSA, E minus I omega T, I will be left with V times E minus VE minus IK. From the second term, similarly, I will have minus M2 omega square V equal to C, okay? Here, I still have this thing over here, so I have UEIKA, okay? Minus V minus C into V minus U. Now, I take everything to the, I will just remove the brackets. So I will have minus M1 omega square U. This is equal to C. If I take here C as common, I will have C into 1 plus E minus IKA times V minus 2CU. Okay, so what did I do here? Here I just took out the brackets. I have CV minus CU minus, sorry, CV minus CU minus CU plus CV e to the minus IKA. Okay, so this gives me what? This gives me minus 2CU, so it is here, minus 2CU, plus CV, take it common, into 1 plus e to the minus IKA, and this is what we see over here. Okay, the same thing in the second equation, I just remove the brackets, so I will have minus M2 omega square V is equal to C into e to the IKA plus 1U minus 2CV. Now I have two equations. I'll take everything with U together and whatever is in V together. So I have U into M1 omega square minus 2C. I brought minus 2C. Or you can say that I took minus M1 omega square U to the other side. So I have U into M1 omega square minus 2C plus V into 1 plus E minus IKA. C is equal to 0. And from the other one, it looks similar. These are equation 3.1 and 3.2. We need to obtain a solution. To obtain a solution, we must have whatever is multiplied by U here. Okay, you can find it here. And what is multiplied by V here, you find it here. Okay, and then also we must have this thing here. And these are two equations into unknown, so this is how we solve it. Is equal to 0. Okay. Now, what does this mean? We will have, in order to solve this, we find the determinant. Okay. So we do M1 omega square minus 2C multiplied by M2 omega square minus 2C. Minus C square into 1 plus E minus IKA into 1 plus E plus IKA is equal to 0. I removed all the brackets. I have M1, M2 omega square minus 2C, M1 omega square minus 2C, M2 omega square plus 4C square minus C square into, so this is now the second term over here. I cross product, I open the brackets here. So I have 1 plus E minus IKA plus EIKA plus 1 is equal to 0. But this thing over here is nothing but 2 cosine KA, because here you need to remember that E to the IKA is equal to cosine KA plus I sine KA. Okay, so I have e to the IKA, it is like this, and then I have e to the minus IKA. So this will give me cosine KA, same thing, but minus I sine Ka. So the signs will disappear, but I will have 2 of the cosine Ka. Okay, implies M1 M2 omega to the 4 minus 2c into M1 plus M2 omega square plus 2c square. I'm going to take 2c square common because here I have 4c square minus 2c square minus 2c square cosine Ka. So I will take 2c square common into 1 minus cosine Ka is equal to 0. And finally, I will have, instead of 1 minus cosine Ka, I will put sine 2 sine square Ka over 2. We have seen this before. Okay, so here I have 1 minus cosine Ka. I will put 2 sine square Ka over 2, and now I have this formula. And we're gonna take the long wavelength regime again. That is 1a much less than lambda, or Ka is going to 0. In this way, sine Ka over 2 will be almost Ka over 2. So I will have the same thing, but instead of sine square Ka over 2, I will have Ka over 2 square. And if I remove brackets, I will have M1 M2 omega to the 4 minus 2c into M1 plus M2 omega square. I will have here 4 square. With the 4 square, they disappear. So I will have c square K square A square is equal to 0. This is now a quadratic equation. Okay, this is a quadratic equation with omega square as our unknown. Okay, we have A equal M1 M2, B equal minus 2c M1 plus M2, and C equal C square K square A square. Okay, so in order to solve this quadratic equation, we first find delta, and delta is b square minus 4ac. So if I put this b square minus 4ac, I will get this delta. And now what are the solutions? The omega square is minus b. Okay, so I find delta, and after I find delta, I will get omega square equal to minus b plus or minus square root of delta altogether, everything here, divided by 2a. Okay, and this is exactly what we did here. So we got omega square now. This is equal to minus b, and we said b is 2c into m1 plus m2, so it is 2c into m1 plus m2 plus or minus square root of delta divided by 2a, 2a, which is 2 m1 m2. So I did a little bit of math. 2c into m1 plus m2 plus or minus 2c. I got the, because here I have 4c square and here I have 4c squares. And here I have M1 plus M2 square. So I took outside 2c into M1 plus M2 square root of, what will remain here is only 1 minus M1 M2 over M1 plus M2 square, because I took it outside. So I have to divide by it here, K square A square divided by 2 M1 M2. Knowing that Ka is going to 0, then the square root of this thing will be 1 minus half M1 M2 over M1 plus M2 square K square A square. So we obtain omega square equal 2c into M1 plus M2. I just copied this thing here by substituting 1 minus M1 M2 over M1 plus M2 square K square A square by 1 minus half this term. I know it's lots of math, but if you just follow it, it's easy to see. Now I have 2 roots because I have omega square. So I have omega square plus and I have omega square minus, okay, because I have 2 roots. Remember, I have here plus, here I have plus or minus. So I have 2 roots. I will call one of them omega plus square, and this will be 2c into m plus m1 plus m2 plus 2c into m1 plus m2, etc. And the omega minus square will be by taking the minus. Okay, I have two roots. So what is the first root? The first root is 2c into m1 plus m2 plus 2c into m1 plus m2 minus c into m1 plus m2 over m1 plus m2 k square a square over 2 m1 m2. And this is equal to, here we are again saying that ka is going to 0. Okay, so this term over here is going to 0. And what I will have left is 4c into m1 plus m2 over 2 m1 m2. I mean, remember that I'm taking the case where Ka is going to 0. So the whole this term disappears, and I will have omega plus square equal, almost equal to 2c into m1 plus m2 over m1 dot m2. And this is nothing but 2c into 1 plus m1 plus 1 over m2. We substitute this in equation 3.1, which is u into m1 omega square minus 2c plus v into 1 plus e minus ika c is equal to 0. I just substitute these things, okay, and follow the math. You will get u over v equal minus m2 over m1. What does this mean? This means that the atoms will vibrate against each other, okay, but their center of mass is fixed. If the atoms carries opposite charges, we may excite a motion of this type with the electric field of a light wave, so that this branch is called optical branch. Okay, so we call this thing, this branch, which is omega plus, we call it the optical branch because they are vibrating against each other. Okay, notice they are vibrating against each other, but their center of mass is fixed. Okay, let's take the second root, which is the minus 1. I'm not gonna go through all the math. We'll just put minus here, okay? And the Ka square again will disappear. So what I will have is, what do we have here? Okay, notice here we cannot actually get rid of the Ka. Here what will disappear is this term and this term because they are exactly the same. And now I have c into m1 plus dot m2 over m1 plus m2 k square a square over 2 m1 dot m2. The m1 m2 cancels out with m1 dot m2, and I will have the negative branch to be c over 2 into m1 plus m2 k square a square. If we substitute this in this equation, I will have u equal to v. So the atoms and the center of mass move all together. And in the long wavelength regime, we call these acoustical vibrations. So this mode, we call it acoustical branch. Okay. So this is omega as a function of k, the negative one. This is omega plus as a function of k. Okay, it's actually not a functional of k, it's constant. It's a function of m1 and m2. And finally, what is happening at the Brillouin zone? The Brillouin zone is when Ka is equal to plus or minus lambda. So we go back to our equation m1 m2 omega square minus 2c into m1 plus m2 omega square plus 4c square Ka over 2. Instead of Ka over 2, I'm gonna put pi. Pi over a. So this term sine squared K over 2 will disappear, and I will have m1 m2 omega to the 4 minus 2c into m1 plus m2 plus 4c squared equal to 0 because sine square of pi over 2 is 1. And to find the roots, I repeat, first I get the delta, and then I get omega plus and omega minus. So this is what's happening over here at K equal plus pi over a and K equal minus pi over a. I have two values. One of them is a square root of 2c over m2, and one is square root 2c over m1. The optical branch is what we see up here. Okay, this is the omega plus. which is 2c into 1 over m1 plus 1 over m2. And what we see here is, this is actually only at the long range, which is here. Which is here. Around this area, notice it is not a function of k, it's a straight line. It's a function only of m1 and m2. The same thing here, the acoustical branch around 0, we found the equation for that. Okay, so we have omega square at all values of k. And whatever zone is here, this is forbidden. Okay, so this is what happens when we have diatomic lattice. Next time, we'll try to solve some exercises to see these things, to understand these things clearly. But I advise you from now till then to go through all the math, to make sure you understand all the math, okay? Because in the exercises, I'm not gonna go through the math again. Okay, so that's it for today. Bye-bye.